Today we're going to take a look at Chapter 17, Electrochemistry. So a couple of things about oxidation and reduction are how you transfer electrons. The loss of electrons is oxidation, and then those electrons that are lost are gained via reduction. And so oxidation and reduction are called half reactions, and they make up half of what's going on. So when you lose electrons in oxidation, those electrons are transferred via the other half reaction, and you have a gain of electrons. And a way of remembering it is Leo the lion says grr, LEO, loss of electrons, oxidation, grr, gain of electrons is reduction. Another way to remember it is oil rig. Oxidation is loss, OIL, oxidation is loss, rig, RIG, reduction is gain. Or let's go on. And where they happen, where the half reactants happen, you can remember via car and auto. The cathode is the type of electrode where a reduction happens, and the anode is the electrode where oxidation happens. So if we take a look, here we have a loss of electrons because two electrons are traveling away from the anode. And so oxidation is happening here because oxidation is a loss of electrons. So over here, the zinc metal is becoming zinc ion in the solution. And so what's happening to the mass of the zinc electrode is the mass of zinc is being converted into zinc ion here. So the mass of this electrode, or the anode, is decreasing. Now what happens is the electrons are transferred because they're lost via oxidation here at the anode, and they're transferred to the cathode. So let's take a look at that. So now the electrons are traveling toward the cathode, and we're gaining electrons. So in the process, the copper 2 ion is combining with the electrons to be reduced, and the cathode itself is gaining electrons because remember, gaining of electrons is reduction. So reduction is happening here at the cathode. The electrons are traveling toward the cathode, and then the mass of the copper is increasing. Now, the mass of the copper is not increasing because we've added 2 electrons here to it. The mass of the copper is increasing because the copper 2 ion is being reduced into copper solid. And where you see redox in everyday life, you find it in a battery. And so you have those there. So when we put them all together, here we have another galvanic cell or another battery where we have copper and we have silver. And so in this case, copper is the anode and silver is the cathode. And so the silver is gaining electrons. And so reduction is happening here at the cathode on the right. And then over here on the left, we have a loss of electrons from the copper. So basically, the electrons travel from the copper because they're being the copper is being oxidized, and the copper is being oxidized into copper 2 ions, and the electrons travel through, and then they're gained at the cathode. And so then the silver ion is combining with the electrons that are being gained here to make silver at the electrode, so at this cathode here. Now in between here, we need something to balance out the charges. And so here we have a salt bridge here. So what happens is over here in the cell on the right, we have, or in the half cell, we have silver nitrate, and that's dissociated. And so what happens is as the silver is the silver ions combining with the electrons, then the nitrate needs to balance out the charge. So in the salt bridge, we have a salt, and so the potassium, which has a positive charge, is being attracted to the nitrate, which has a negative charge. And conversely, in the other half cell, where the anode's here and the oxidation is happening, what we have is the copper 2 is combining with the nitrate to balance out those charges. And then in the salt bridge, we have potassium nitrate. And so those electrons, those ions go there to balance out the charge. And in effect, what we have is then the transfer of electrons creates voltage by having current travel through over a certain amount of time, and we make a certain amount of volts. And so what happens is in a galvanic cell, the volts will be positive, and we'll talk about how we can calculate that a little later this week. Now we're going to take a look at line notation and half reactions for what we have in a galvanic cell. if we take a look here, the electrons are traveling away from this side. So then that means that if they're traveling away, this is the anode. And remember, the anode is where oxidation happens. And how we remember that? A, anode, and O, oxidation, auto. Anode is where oxidation happens. And remember, oxidation is a loss of electrons. Because LEO, loss of electrons, is oxidation, or oxidation is loss, like oil. And then that means that then this is the cathode, because we're gaining the electrons over here. And then this is reduction, just like car, CAR. So this is where reduction happens. And we have a gain of electrons, rig, oil rig, or GER, G-E-R, gain of electrons is reduction. So when we express it in line notation, what we do is we just write these out. So if we're going to take a look here, we need to write down this oxidation. So in oxidation, what's happening is the copper is becoming the Cu2 plus. So here, well, let's write this down. So we have copper becoming Cu2 plus. And then we need to balance out the charges by adding the electrons to one of the sides. So it's pretty apparent here that if the charge is 0 on this side and this is +2, remember electrons have a negative charge. So then that means we need to add 2 electrons to the product side, because that'll make it so it has a net charge of -2. So +2 and -2 equals 0. Now remember, it's not always going to be 0 and 0 for the total charges on either side. It could be -1 and -1. It just depends. But in this case, since we have the copper becoming Cu2 plus, then we're going to have 2 electrons to balance that out. All right, so this is oxidation. So I'll just write an OX here. And then we also have reduction on the other one. So in this case, since the electrons are being gained, that means that the Ag plus the electron should be on the reactant side, because we have a gain of electrons. And this should become Ag. And then so this is reduction because we have a gain of electrons. And then to balance out the equation, we would just need to make sure that the electrons are equal. So we have 2 electrons here, like we've seen before in chapter 4 when we balanced half reactions. And then so we need to multiply the reduction half reaction by 2 to make it so there's 2 electrons. So if we add them up, we end up with 2Ag plus Cu yields 2Ag plus Cu2 plus, and the electrons had canceled out here. If we take a look here, then we have 2 silver atoms on the reactant side, 2 silver atoms on the product side, 1 copper, and then the total charge +2 plus 0. So that's +2 on the reactant side, and then 0 plus 2, that's +2 on the product side. So the charges and the number of atoms are equal. Now in line notation, what we do is we're going to write down what we have here first with oxidation. So we're just going to write Cu, and then we're going to write a line, and then Cu2 plus, and then we'll draw a double line to represent it's between the 2 different cells. And then what we'll do is we'll take the silver, Ag plus, we'll put a line, and then we have an Ag, and then that's it. So what ends up happening is the electrodes are always on the outside. And then the solutions are always on the inside that we have here. So if we take a look here, this is the anode. So the anode will always come first on the left, and the cathode will always be on the right. And then the other thing that you'll notice is that when we write it out, Cu yields Cu2 plus matches the order that it is over here. And then the Ag plus yields the Ag, and that'll match the order that we have over here. Now there's one more setup I wanted to show you, is what if we had 2 ions in the solution, and then if we have 2 ions in the solution and the ions are getting oxidized, one of the ions is getting oxidized into the other. Platinum is used as the electrode to help facilitate if we have aqueous solutions only, and no solid electrode, or if we had a gas and an aqueous, like you might see with, say, a chlorine gas and a chloride ion. So platinum is used as the electrode. So what happens here is, well, if we have oxidation, remember the oxidation number needs to go up. So it'd be Cu plus yields Cu2 plus, and then we would have one electron here as the loss of electrons. And then the other cell where I had the reduction going on is still the same. So we still have the reduction. So Ag plus becomes Ag. And then if we remember from back before, this has a +1 oxidation number. This has a 0. So the oxidation number went down because we gained an electron here. And then the electrons would cancel out, and we would just be left with Cu plus Ag plus yields Cu2 plus Ag. And you'll notice the charges and the number of atoms are equal. Now, how do we express this though? Well, remember we need to put the electrode here. So we would put PT. We draw a line. And then what we do is we would put these in order. So we'd have Cu plus, and we put a comma, and then Cu2 plus. And then we would put our two lines to show the separation between the oxidation and reduction between the anode and the cathode. And then we would put, like we had before, Ag plus, and then Ag. So like before, this is the anode. This is the cathode. The half reactions that we'll see, Cu plus yields Cu2 plus, and then plus the electron, because that's the order. And then we have Ag plus E minus yields Ag, like we saw down here. Now, if we don't express the concentrations of the ions, it's assumed that in a standard solution, we would have 1 molar or 1.0 molar. So if anything changes, we would have written in parentheses whatever the different molarity would have been besides 1.0 molar in the standard solution. And you'll see that in your textbook too, just in case. So hopefully this puts it all together, and you'll do some practice with line notation and half reactions.